Alright, hi everyone. We're going to do a short screencast here where we're kind of looking at how to set up a dihybrid cross. How do you do that successfully without having to automatically go to a Punnett square that is 16 squares in size, 4 by 4. So we'll do it in 3 steps, and this first slide is about figuring out the number of possible gametes for a genotype. And so what you do is you use 2 to the n. Okay, 2 never changes in this little mathematical trick. The n does. The n is a number of heterozygous genes that are present in the genotype of the parent. Okay, so we'll do a couple examples to kind of illustrate this. So we take our big R, big T, little t. This is the genotype of a parent. I'm going to underline the heterozygous genes. Can you guess what they are before I do it, though? Well, big R, little r is heterozygous because we've got a big with a small, a dominant with a recessive, and big T, little t is also heterozygous for that reason as well. So when we do 2 to the n here, there are 2 heterozygous genes. What's 2 to the 2? Well, it's 2 times 2. And we're going to get 4 possible gametes from that particular genotype. When we look at the next example, again, we're going to do 2 to the n. Where are the heterozygous genes in this particular genotype? Well, it's big R, little r again, and we've got a big with a small, a dominant with recessive, but little t is homozygous recessive, so that's not heterozygous. So my n is going to be 1 here. 2 to the 1 is 2. Alright, so if we were doing a Punnett square with this particular cross, then a Punnett square would end up being 4 by 2. Okay, let's go to the next slide. The next slide is about figuring out the dimensions of a Punnett square for a dihybrid cross. So again, the process is exactly the same. Again, it's about not having to fill in a Punnett square that is 4 by 4 all the time, which is pretty labor intensive. So here's an example. I've got 2 parents here, and they have 3 sets of genes. Again, we have to figure out what are the heterozygous genes in each of these parents. So big T, little t is heterozygous. Big G, little g is. Big R isn't. And so my n is now 2. 2 to 2 equals 4. When I look at the other parent, again, the only heterozygous gene that is there is the G's. So that's big G, little g here. The T's and the R's are both homozygous. So my n now is going to be 1, and that gives us 2. So I now know that my Punnett square size, in order to successfully solve this without a ton of work, is going to be 4 by 2. And so I take and my next step, of course, then is to figure out the gametes from this parent and write along the top, and then figure out the gametes for the other parent and write it along the side, which is what the next slide is about. Figuring out the possible gametes in a dihybrid cross. So take a moment and pause and see if you can do this. Okay? So I'm back, and I'm going to go through this process of figuring out the possible gametes in a dihybrid cross. So again, I'm going to use 2 to the n. So 2, what's the heterozygous genes here? Well, it's big R, little r, so 2 to the 1 gives me 2. When I look over here, I just got big R, little r again, so it's again 2 to the 1 is 2. So now when we figure out the possible gametes, we want to make sure that there's at least 1 letter from each type of gene that's represented in the genotype of the organism. Okay? So when I figure that out for this parent here who's red, there are 2 possible gametes. So one of them is a big R and big T. Okay? The other one is going to be little r, big T. Okay? I can't write down big R, little r, because that would produce a gamete that doesn't have any T information in it. Whatever T is actually representing. I can't have a gamete that's big T, because again, that gamete will be missing R information, and that's no good either. Over here, again, I want to make sure that I have an R, a B, and a G in all the gametes that I'm going to be writing down. So there are 2 possibilities. What are the 2 possibilities? Well, let's back that up. and change that color to green again. So it's big R, big B, and little g. What's the other one? Well, it's little r, big B, little g. Well, why don't we have any little b's or big g's in my gametes? Well, they're not provided in the genotype of the parent. Okay, so when you're figuring out the possible gametes, go through this process. Do 2 to the 1. Make sure that each gamete has one letter represented from each of the gene sets that are present in the genotype of the parent, and go from there. Now, of course, if I want to then go solve my Punnett square, my Punnett square is going to end up being 2 by 2, and then I'm going to put these 2 possible gametes on the top, these 2 gametes here along the side, and then I'm going to fill my Punnett square in to solve. Okay, so hopefully that's helpful, and see you soon.